Well, hey everyone, glad to be with you today. My name is Jeff Bartley. I'm excited to be with you. I'm joined today by Kirill Davidichev, who's a storage solutions architect here at Amazon Web Services, and I am a product manager on the AWS DataSync team, and we're excited to talk to you today about some of the things that you can do, some of the best practices when you approach moving your data both online and offline. From an agenda perspective, so we're going to talk a little bit about, give a data migration overview, what some of the capabilities are that AWS offers in this area. And then we'll go into looking at the difference between online versus offline and some of the things you want to take into consideration when you're thinking about those choices. We'll then jump into an overview of DataSync. And then we'll talk through an overview of Snow Family, and I'll turn it over to Kirill to talk about the Snow Family. We'll then finish up by talking a little bit about how you can potentially use those two together and close out with some thoughts and resources on that. So first, let's talk about kind of the challenges that are associated with large-scale data migrations. And when we talk about large-scale data migrations, we're talking about hundreds of terabytes or even petabytes of data, millions of files. We're talking about a lot of data that needs to be moved. And typically there's challenges associated with moving that much data. You have to think about, if you're building it yourself or if you're doing it yourself, there's managing those scripts, there's a work and time involved in doing that. You also have to think about things like managing bandwidth if you're doing an online transfer. How do I make sure that I'm using enough bandwidth while not at the same time potentially saturating my network? You have to think about things about like, well, how do I deal with recovering from errors if they occur? How do I deal with encrypting and validating my data? Validating data is really important, of course. You want to make sure that your data ends up at the end just like what you began with. And so you want to make sure that you copy that data correctly. And then you want to ensure that you're getting the proper performance. Of course, when we're talking about data movement, data migration, speed is of the essence. You want to move data as quickly but correctly as possible. So you want to balance the performance against the correctness. So these are some of the challenges as we've gone out and we've talked to customers, particularly customers who are looking to migrate into AWS. These are some of the challenges that they've faced in the past. Now, AWS has a number of services and capabilities to help our customers with data migration. Whether you're talking about using something like AWS Transfer Family, where you're looking to move data over specific protocols like SFTP or FTP, or whether you're looking at DataSync for online data transfer capabilities, or maybe you're looking to migrate your virtual machines into AWS and you want to look at cloud migration, or you're thinking about some of those offline capabilities, or whether you're looking to migrate your databases using AWS data migration tools. Or perhaps you're looking for a hybrid capability where you want to not only copy your data, but you want to still access it from on-premises. That's where something like AWS Storage Gateway can come into play. Well, today we're going to focus on two of these services in particular, AWS DataSync and AWS Snow Family, where DataSync is really focused on that online data transfer capability, while the Snow Family of services is focused on offline data movement. So when you're thinking about online versus offline, these are some of the things that you want to consider. First, you want to take into account what kind of network bandwidth you have available. Do you have a lot of network available or maybe not so much? And the key word there is available, because you may have a very large network bandwidth capacity, but maybe only a portion of that is available to your data migration. So you want to take into account what is actually available to use for your data movement and your data migration. You also want to take into account things like firewall configurations. Online data movement is going to happen over your network, so you have to think about what ports and capabilities are going to need to be configured on your firewall. And then you also want to think about the fact that that data is going to be available immediately, and are there things that you can do to react upon that. From an offline perspective, it's really more oriented in cases where either you don't have a lot of bandwidth available, or maybe that network capabilities that's available to you is spotty. It's not a great network connection, and it would be better to go through an offline data transfer capability. You also want to think about some of the requirements of managing devices, because with an offline capability, something like Snow family of devices, those devices are going to be shipped to you. They're physical devices. You're going to install them into your data center, connect them into your network. There's work required to do that, and so you want to make sure you have the capabilities and the people to be able to do that for you. And then you also want to allow time for data import, because just like the device was shipped to you, when you're done filling it up, you're going to ship it back. It's going to take time to pull data off of that device. So those are some of the things you want to consider when you're thinking about that online versus offline data migration decision. And then this is just kind of a matrix of where some of those services are that we talked about, right? So with AWS Transfer Family, it's really focused on these business-to-business type transfers, or these data transfer workflows. Whereas something like a DataSync or a Snow, they're going to be focused on these large-scale data migrations. And for maybe that hybrid cloud access, you can look at something like Storage Gateway to give you that on-premises access to your data that's stored in the cloud. Okay, and then so we put this chart together just to help our customers kind of understand a little bit better and to kind of visualize where a threshold can be when you're considering online versus offline migration, specifically when you're thinking about selecting Snow versus DataSync. And what it shows you is, given a certain amount of data and an available network bandwidth, what's the cutoff? What do you want to think about, right? So if you've got a very large amount of network bandwidth available, something in the order of 10 gigabits per second, you can move a lot of data fairly high rates. And so online makes sense. You probably want to go with AWS DataSync. Whereas if you have low network bandwidth capacity or capabilities in the 1 gigabit per second range, maybe even lower, Snowball is probably going to make more sense for you in that regard. But this is just kind of a way to get an idea of, given the amount of data to be moved, given the network bandwidth available to you, what kind of makes sense from a service perspective. So with that, let's jump into an overview of AWS DataSync. So we talked earlier about those data migration challenges, right? Thinking about things like encryption and validation, thinking about recovering from errors and things like that. So DataSync was built to address many of those challenges, and it's an online data transfer service that's designed to make it easy for customers to move large amounts of file and object data into or out of AWS storage. We've designed it to be fast, so it uses a custom-built parallel transfer protocol that's also resilient to network issues as they arise. It can deal with things like network disconnects or TCP retransmits or things like that. It's also designed to be easy to use, and security, as always, is job one here at AWS. So DataSync encrypts all data in transit. It also supports encryption at rest as well. And all data is transferred. We validate all data transferred both in flight and at rest, byte for byte, so you can be sure that your data was copied correctly. It's a fully managed service, which means we take care of a lot of the heavy lifting of connecting to AWS storage services and all the networking involved there. And it's designed to be low cost. At 1.25 cents per gigabyte of data transferred, you only pay for the data that you move, and there are no minimums to that. So when we go out and we talk to customers, and I talk to my customers who are using DataSync today, they're really falling into kind of 4 key categories or 4 key use cases. The first are customers who are looking to migrate their applications into AWS. And in this case, they've got their applications, and very often those applications have data somewhere on premises that they need to move along with the application. That data may reside on, maybe it's a Windows server or a NAS file system, or maybe an object storage system. And so the customers will use DataSync to migrate that data along with their applications. So when their applications are now running in AWS, they have easy access to that data just like they did when they were on premises. I've also got customers who have a lot of data on premises that is cold. That means this is data that's not being accessed very often, and they want to move that data somewhere else so that they can either free up their capacity or maybe even shut down those storage systems entirely. And often these customers are using DataSync to move their data into S3, maybe into Glacier or Glacier Deep Archive, to be able to take advantage of the low cost of storage in those particular storage classes. I also have customers that are using DataSync to replicate their data. So they want to maintain their on-premises storage, but they want to replicate their data into the cloud, maybe for disaster recovery purposes, maybe for additional data protection purposes. But regardless, DataSync has scheduling capabilities that allow them to easily make incremental transfers of their data over time up into the cloud, give them that added protection of their data. And then finally, I've got a lot of customers using DataSync for what we tend to call ongoing data transfer workflows. And you can think of customers like those in the life sciences industry, where they have instruments or devices on premises that are generating a lot of data. And these customers, they want to bring that data into the cloud so that they can process it. They might want to do further computation on it. They might want to do analytics, maybe some AI or machine learning on it. And of course, AWS has a lot of services that enable our customers to do those kinds of things. And so they're using DataSync to copy that data from on-prem into the cloud. And then once the processing is complete, they're taking the output of that processing and copying it back on premises so that their users or their scientists can continue to work with that data. So AWS DataSync is available today in 23 regions across the world, and as new regions come up, we continue to add support for those. So what can you do with DataSync? Well, it's kind of three key areas, and we've referenced these a little bit, but the first of these, of course, is enabling you to move data between your on-premises storage environment and AWS. And we support storage that supports the NFS or SMB protocols, as well as object storage systems that support the S3 API. We also recently launched support for Hadoop clusters. So DataSync can now copy data from the Hadoop file system that's on your Hadoop cluster up into AWS. And you can also use DataSync to copy from AWS back onto your Hadoop cluster. So this has been really exciting for our customers who are either looking to migrate their Hadoop clusters into AWS or maybe have these ongoing processing or of their systems that they want to do in the cloud as well. DataSync also has a presence at the edge. So AWS Snowcone, which is a device that Kirill is going to talk about here in a little bit, comes pre-installed with the DataSync agent. So customers can use DataSync directly from the Snowcone device. They can put data onto the device, and then they can use DataSync to copy from the device up into AWS directly without having to ship the device back to AWS. DataSync also supports helping customers who need to copy data between their S3 buckets in region to their Amazon S3 on Outpost buckets. Outpost provides compute and storage capabilities at the edge, and Amazon S3 on Outpost gives customers the same experience that they would have using S3 buckets in the cloud. And then finally, our customers are using DataSync to copy data between managed storage services directly within AWS. So for example, you could use DataSync to copy data between one S3 bucket and another, or you could potentially copy data between an EFS file system and S3. Any combination of those storage services that we provide or that we support, DataSync can copy between those. So diving a little bit deeper on this, just as kind of an understanding of how DataSync works with these on-premises storage transfers. So as I mentioned, we can talk to storage that talks NFS or SMB. This is typical NAS file servers, Windows servers, things like that. I also mentioned object storage and Hadoop clusters. Those storage systems are accessed using an agent. A DataSync agent is a virtual machine appliance that you install in your VMware, KVM, or Hyper-V environments. And then the agent connects to the DataSync managed service that's running in AWS. And that connection between the agent and the managed service, again, is fully encrypted and it's highly parallel. That's using our custom protocol to provide that high performance and resilience against the network. And then the managed service takes care of copying the data to the storage services that you desire. We also support, when we're talking about on-premises connectivity, DataSync supports 3 types of endpoints for getting your data into AWS. The first of these is what we call a private endpoint or a VPC endpoint. And this gives you the ability to get private connectivity between your on-premises environment and AWS. We also provide public endpoints for customers who maybe don't have a direct connect, which they would use with a VPC endpoint, or perhaps they just have a faster connection over the internet. They can copy their data over the internet directly into AWS. And then you can also use DataSync with FIPS endpoints, which are commonly used for customers, mostly in the US, who are working with government agencies or things like that and need that extra level of compliance. So let's also talk about how DataSync is used for these transfers between storage services. So I talked about this a little bit, but some of the advantages here are that because the storage services are entirely within AWS, there's no need to deploy any infrastructure. DataSync takes care of setting up the networking connectivity between your different storage services and transferring the data without requiring any setup of any resources or managing any resources in your cloud. And the other nice thing about this is that all the data that's transferred is transferred over the AWS backbone. So it stays entirely within the AWS network. And using this, you can either copy between storage resources within the same region or across regions. And all data, just like with on-premises transfers, is encrypted in flight using TLS 1.2. So let's dive a little bit deeper into how AWS DataSync works. So we talked about, this is really focused on on-premises transfers. So as I mentioned, the first step when you're using DataSync for your on-premises transfers is to deploy an agent. And again, an agent is a virtual machine appliance that you deploy in your environment, in your virtual machine environment. And then you create locations. So DataSync has this concept of a location, and a location could be an NFS server. It could be a Windows server. It could be a Hadoop cluster. It could be an S3 bucket, an EFS file system. All of those different storage systems and capabilities that we support, those are locations. And DataSync copies data from a source location to a destination location using a task. So once you've defined your locations, you then create a task. And the DataSync managed service takes care of running that task and copying the data for you from the source to the destination. It takes care of data validation, verifying all the data in flight and at rest. And as I mentioned, DataSync can copy data either over Direct Connect or over the internet. We have a number of capabilities and endpoints to give you that flexibility in how you want to connect into AWS. So a common pattern that we find with our customers where they're using DataSync is that they want to archive their data into the cloud, but in some cases, they still want to be able to access that data from their on-premises environments. And so this is where both DataSync and Storage Gateway can come into play. So customers will start by deploying a DataSync agent, copying their data from their on-premises storage systems up into AWS, typically S3, but you could also copy into FSx or Windows File Server. Storage Gateway supports both of those. Then once that data is copied, customers will then deploy a Storage Gateway in their on-premises environment and connect it to those AWS resources. And the advantage here is that customers can now fully work with that data that's stored in AWS. They no longer need their on-premises storage, but the data is stored in AWS durably and reliably, but they still get that low latency on-prem access through Storage Gateway. And in fact, one of our customers, F1 or Formula One, who's they run a very popular racing organization, and they use this particular pattern because what they had was, as a racing organization, they're collecting a lot of video for every race, and they had a 400 terabyte archive of this video that they were looking to store in the cloud. They wanted to make a second copy of that data just for disaster recovery purposes if needed. But they also wanted to make sure that they could access that data on premises if needed as well. So what they did was they used DataSync to perform that initial copy of that 400 terabyte archive into Amazon S3. And then they deployed a storage gateway in the file gateway mode and connected it to their S3 bucket. That gave them that on-premises access to the data if they needed it, if that on-premises storage ever became unavailable. And then they continued to use DataSync to make incremental copies of new video archive and footage as it came into their archive. They would copy that using DataSync from their on-prem storage up into S3. So this gave them the ability to move data quickly, to continue to copy new data as it came in, to take advantage of the durable storage that Amazon S3 provides, and then still giving them that on-premises access to data in the cloud if needed for emergency purposes. And this is a quote from one of the engineers at Formula One about the great experience that they had using DataSync. It was quick, it was fast, and it gave them that ability to do those incremental transfers as needed. All right, and with that, I'm going to turn it over to Kirill, who's going to talk to us about the AWS Snow family.
Thank you, Jeff, and hi, everyone. So what is the AWS Snow family? The AWS Snow family helps customers that need to run operations in austere, non-data center environments and in locations where there's lack of consistent network connectivity. The Snow family, comprised of AWS Snowcone and AWS Snowball, offers a number of physical devices and capacity points with built-in computing capabilities. These services help physically transport up to exabytes of data into and out of AWS. Snow family devices are owned and managed by AWS and integrate with AWS security, monitoring, storage management, and computing capabilities. AWS Snow family provides a set of services and functionality on the partially to fully disconnected and secure edge. It enables data collection, data processing, and data movement from edge to AWS. AWS Snow family also provides edge infrastructure and software that moves data processing and analysis as close as necessary to where data is created in order to deliver intelligent, real-time responsiveness and streamline the amount of data transferred. In this session, we will be focusing mostly on the data movement capability of Snow devices. We recommend using Snow family devices for data movement when bandwidth to the internet is limited or unreliable. For example, some use cases include offline operation on oil drilling platforms and ships, self-driving vehicles, film production crews that often operate out of hotels or in remote areas where high-quality video cannot be uploaded using online methods, and so on. AWS Snow family devices use tamper-resistant enclosures, 256-bit encryption, and industry-standard Trusted Platform Modules, or TPMs, that are designed to ensure both security and full chain of custody for your data. All data copied to Snow automatically encrypts using 256-bit keys that you manage by using the AWS Key Management Service, or AWS KMS. Encryption keys are never stored on the device. This helps ensure that your data stays secure during device transit. The TPM provides a hardware root of trust. Specifically, they are designed to detect any unauthorized modifications to the hardware, firmware, or software on the device. AWS uses additional tamper-indicating inspection processes after each Snow device is received back to the AWS region to ensure the integrity of the device. With the Snow Services encryption features, it helps preserve the confidentiality of your data, and of course, the devices are wiped after data transfer according to National Institute of Standards and Technology, or NIST, guidelines for media sanitization. Snow offers core AWS services like EC2, EBS, S3, IAM, IoT Greengrass, and Lambda on the device, and offers the same AWS APIs that you're familiar with using in the cloud. Currently, the Snow family consists of two types of devices, Snowcone and Snowball Edge. The AWS Snowball is a service that provides secure, rugged devices so you can bring AWS computing and storage capabilities to your edge environments and transfer data into and out of AWS. Snowball Edge is an edge computing and data transfer device provided by the AWS Snowball service. It has onboard storage and compute power that provides select AWS services for use in edge locations. Snowball Edge comes in two options, storage optimized and compute optimized, to support local data processing and collection in disconnected environments such as ships, windmills, and remote factories. The Snowball Edge Storage Optimized has 80 terabytes of usable storage, accessible via either S3 or NFS protocols. It is about the size of a suitcase and weighs under 50 pounds, so it can be easily moved by one person. It has convenient carrying handles, and since it's ruggedized, it ships as is without the need for any boxes or packing materials. The Snowcone is a small, rugged edge compute and data storage product. Running applications in austere edge environments or where is lack of consistent network connectivity or low bandwidth can be challenging because these locations often lack the space, power, and cooling needed for data center equipment. With two virtual CPUs, 4 gigabytes of memory, and 8 terabytes of usable storage, or 14 terabytes for the Snowcone SSD, all Snowcone devices can run edge computing workloads that use Amazon EC2 instances and store data securely. Snowcone's small size, around 9 by 6 by 3 inches, enables you to set it next to machinery in a factory to collect, format, and transport data back to AWS for storage and analysis. The Snowcone weighs 4.5 pounds, so you can carry it in a backpack, run it off an external battery, and use either the wired network interface or Wi-Fi to collect data. The Snowcone device supports data transfer from on-premises Windows, Linux, and macOS systems using AWS Ops Hub. It also has an NFS interface, so it can be used with any file-based applications that support NFS, just like any other network-attached storage device. You can collect and process data at the edge, and you can ship the device with data to AWS for offline data transfer. You can also transfer data online with AWS DataSync from edge locations. Snowcone stores data securely in edge locations. A Snowcone device is ultra-portable, so you can carry one in a backpack or fit it in tight spaces for IoT, vehicular, or even drone use cases. For mobile or portable workflows, you can power the Snowcone device using a battery. Ops Hub is a UI-based tool to manage multiple Snow family devices at your edge location. To use Ops Hub, you simply download it and run it on a local host, such as a laptop that is connected to the same local network as Snowcone. You can use Ops Hub to unlock and manage your local and remote Snow devices with just a few clicks. You can use the dashboard to monitor the CPU, memory, and storage resources on Snowcone. For compute applications, you can use Ops Hub to create instances for the AMIs already loaded on Snowcone, and then you can run your applications. Similarly, for data transfer, you can set up NFS file transfer with just a few clicks, and you can drag and drop files onto Snowcone or Snowball. If you can plan to transfer data online to AWS, Ops Hub will help you activate DataSync and initiate the data transfer. You need to select the right solution or tool to complete your data migration, depending on the amount of data to be transferred and the nature of the edge location from where the data needs to be transferred. AWS provides more options for online and offline data transfer than from on-premises or the rugged edge than any other cloud provider. I would like to revisit Jeff's slide from earlier that shows how long it would take to perform an online transfer with a given bandwidth. A common saying in the industry is to never underestimate the bandwidth of a station wagon full of tapes, or hard drives in this case. The latency may not be great, but with a well-orchestrated process, you really can transfer petabytes of data offline faster than online. And the point where offline transfers are typically more efficient is usually when your available bandwidth is less than 5 gigabits. It's important to consider all options when planning a data migration. For example, I've been involved in situations where a customer could potentially get a 10 gigabit connection to their facility, but it would take a few months to install at a great expense, an unacceptable delay for their desired timeline. Snow Family was a very effective option there. In other situations, such as a colo facility, it may be possible to run a 10 gig drop to a cage within 24 to 48 hours, in which case online transfer might be a better option. This timeline represents the average time it takes from when an AWS Snow device is ordered, provisioned, shipped, used, and returned back to AWS for data ingest to S3. Each stage of the process can run between 2 to 3 business days, with a variable unit indicated where you will be copying data. At this stage, if you were to copy 500 terabytes of data offline with AWS Snowball Edge devices, expect it to take about 30 days on average. To copy 1 petabyte of data, you can expect about 60 days. To hit those averages, there are a few assumptions that are made, including optimal conditions, no delays, optimized copy, a fast local network, and ideally, a project manager to oversee the data migration project. There is currently no SLA or guarantee in place for import turnaround time using the Snow Family service. Once a Snow Family appliance is returned to AWS, expect 1 day for handling and setup before import operations can begin. Larger, highly fragmented datasets can take longer to complete the import process. So, long story short, depending on the shipping speed you choose, expect 4 to 9 business days of overhead for the device handling process, and plan for about as many days before all your data shows up in S3 as it took to copy the data to the devices in the first place. One customer example I like to use is Joyn, Germany's first free streaming video service. They used multiple AWS Snowball Edge storage optimized devices to migrate 3.4 petabytes of media to Amazon S3. To optimize their storage costs, they used Amazon S3 intelligent tiering to smartly store data based on how often it's accessed. This solved their challenges of high maintenance costs they experienced when managing their own data on premises. Take a look at these results though. Joyn was able to move 3.4 petabytes in 90 days. This was a major goal for the organization, and AWS Snowball got them there. You can also see they saved roughly $500,000 a year by closing their on-premises data centers with no increase in total cost of ownership. At the end of the project, their media engineer Stefan said that moving their archive using Snowball Edge was fast, simple, and secure, but they were also impressed by how cost-effective it was. Now that all of their content is easily accessible in the cloud, they're able to quickly transcode and deliver content to audiences that they can't find on any other streaming service. We have found the following approach to work effectively for numerous customers, from Photobox to Netflix. The proof of concept is vitally important to ensuring site is prepared to receive and handle the numerous snowballs or snowball edges. The end goal to the POC is to nail down the network, staging workstation, data transfer speeds and tooling, and then determine the appropriate schedule for devices to arrive on site to enable the migration. The ingestion pipeline is in reference to nailing down the software tooling to move the data. Many customers create these scripts themselves because they have to normally, but we see some ISVs out there, like Pixspan, that have optimized data transfer into Snowball Edge in a commercially available UI product. One common issue we see in customers is that the source system, let's say a production NAS system, is limited in the aggregate read rates it can support. This is extremely important to identify in the POC phase. Lastly, one will target a schedule and work with the account team and service team to reserve devices. Once the aggregate throughputs are identified, tooling established, and infrastructure setup is completed, jobs can be created through the AWS console. The orders must align with copy progress and ingestion timeline. As an example, during the POC phase for a 1 petabyte migration, we may prove that the environment has the ability to handle 5 Snowball edges concurrently, and the max throughput measured per Snowball edge is at 1.6 gigabits per second, which results in a need for a total of 13 Snowball edge devices in 3 batches. In this example, one would place the order in such a way to get a new set of Snowball edges every 6 days. It is highly recommended to work with your AWS account team at this point to ensure timely delivery and meet any additional support needs for your project. The Snow Cone is a much smaller version of Snowball Edge, roughly the size of a Kleenex box and weighing 4.5 pounds. It's designed for highly mobile applications like remote crews or sports media teams who need something they can toss into a backpack and securely store and transport digital content. It is a lightweight, power-efficient, vibration-resistant, ruggedized device that makes it possible for anyone to collect or distribute up to 14 terabytes of data and perform pre-processing of data in any location. Snow Cone connects to wired and wireless networks. It is powered by a standard plug or an optional 12-hour battery pack, so you don't even need to connect it to wall power. With 2 virtual CPUs, 4 gigabytes of memory, and 8 or 14 terabytes of usable storage, all Snow Cone devices can run edge computing workloads that use Amazon EC2 instances and store data securely. Snow Cone features a file interface with NFS support. It is commonly used in scenarios where portability is required, or in cases where the amount of data to transfer is less than about 40 terabytes. As I mentioned earlier, you can also use Snow Cone for online transfers with DataSync. And with that, I'll hand over back to Jeff, who will dive deep into that scenario. Thank you.
Well, thanks, Kirill. It was great hearing all about our Snow family of services and their capabilities and how they can enable offline data movement. So now what I want to do is I want to talk a little bit about how you can use DataSync and these Snow family of services together. So the first thing I want to talk about is customers who are using these services together for these large bulk uploads. And a common pattern that we see is for customers who maybe don't have a lot of bandwidth, but they've got a lot of data that they need to move. So they'll start by using Snowball devices. They'll order as many as they need to fulfill the movement of their data. They'll bring those into their data center, fill the Snowball devices with data, and ship them back to AWS so that the data can be uploaded into their S3 bucket. And then once that data is in their S3 bucket and they've verified that it's been copied up there correctly, then what they'll do is they'll continue to do incremental transfers, but this time using DataSync for the incremental transfer, because with this, they're not moving as much data. DataSync is taking care of figuring out only what data needs to be copied. It's intelligent enough to go out and look at the S3 bucket, recognize all the data that was already moved using Snowball, and then only move new data or any changes that are made through that on-premises storage system. And in this way, you can use both of these services together to accomplish these large data migrations where you need to do a bulk upload, do some incremental transfers, validate your data before you do your final cutover of your migration. Another pattern is using AWS Snow Cone. So I mentioned earlier how the AWS Snow Cone device comes pre-installed with the DataSync agent. So what customers will typically do is they'll load data onto the Snow Cone device using an NFS interface, and that gets stored locally on the storage on the Snow Cone device. And then customers can use DataSync to copy directly from that device up into the cloud. They could also choose to send the Snow device back. If they do, that data will be copied directly into their S3 bucket. but it gives them that flexibility to decide how they want to move their data when they want to move it. What I've seen with customers is a common way that they'll use snow cone devices is that they'll be out in the field. Maybe they're doing some camera shooting on site or something like that, and they'll load that data onto their snow cone device. They're out in the field, and then they'll bring that device back to their office, plug it into their network, load up DataSync, and copy the data from the device into AWS, where they'll do the further analysis and processing, whatever they need to do with the data that they've collected. And in this regard, they don't have to send the device back to AWS. They can just continue using it as needed. So some pretty cool capabilities for being able to use DataSync and Snow devices together. So with that, I'm just going to go ahead and wrap up and talk about, if you're interested in learning more about these services, you can head out to our product pages for DataSync and Snow, aws.amazon.com/datasync or aws.amazon.com/snowball. You head to either of these, we've got all kinds of resources for you, blogs, videos, links to workshops and things like that, things to get you going and started with these capabilities. And with that, I just want to say, as one more reminder, we've got a couple of breakout sessions out there that you can go ahead and check out. So there's one for the Snow family, and then there's one for the AWS Transfer family. These are related to data movement and data migration. If you're interested in learning more, definitely recommend you go check those out. And with that, I just want to say thank you. My name has been Jeff Bartley, and it's been great being with you today. Thank you again to Kirill for his help talking about Snow family. Hope you have a great day. Thank you.